Hello, welcome to one of the common, still very important analysis in data warehousing or in big data. First and foremost, we need to understand what are the challenges when it comes to big data. So very common way of analyzing these challenges in big data is looking at their V's or V's properties. There are various number of V's. However, in this discussion, we are limiting our V's to 5. So we are looking at V's of data. So when it comes to V's, there are different types of V's as I said before. So in this slide, you will see 10 V's. If you really look at, depending on which material you are looking into, you will see different types of V's. I have seen articles which describes 38 types of V's, 25 types of V's. However, in this discussion, we are looking at important 5 V's, which are volume, velocity, variety, veracity, and value. On the other hand, you can see into your right side, there are V's like validity, variability, venue, vocabulary, vagueness. I just want to tell you here that there are a lot of V's, but our focus will be on V's which are on your left-hand side of your screen. So let's take one by one. Volume. If you look at, historically, we collect data. However, depending on the platform that you are using, depending on the technology that you are using, amount of the data that you are collecting, storing can be different. To your left-hand side, you can see a picture. Yes, it's not a typo, it's correct. 5 MB hard drive. 5 MB hard drive. It's taller than a human. If you go by this size, it is around 5 cubic meters, which means it's one MB for 1 cubic meter. Now just imagine if you want to store 1 TB of data, considering that the scales remains, 1 TB of data would be size of a building. Now if the technology did not evolve like this, as you know, now it's a 5 TB is at your fingertips. You might be having a phone which large storage which you are carrying in your pocket. If this evolve did not happen, we might not be able to store large volume of data. In 20 years ago, even in Sri Lankan context, we were not able to store large volume of data. Now, with the increase of this technology, hardware technology, space storage technology, now you can store large volume of data. So with the increase of this technology, now users can store large volume of data. Therefore, they can do their analysis better. So this picture again tells you the two types of volume. Typically, if you look at your operational system, such as supermarket data or health hospital data, data comes in small volumes over time. At a given hour, you will get 1,000 orders. So end of the month, you will get 1 million orders. At a time, it's tiny, but if you look at a deep timeline, you get a large volume of data. On the other hand, there can be a data like elephants. That is, you are getting a data as a bulk volume. For example, if you're looking at the video streaming for organization, where you have more than 20-25 cameras, at the same time, you get large volume of data. If you are dealing with IoT devices, that will give you large volume of data. Now, what is the impact of the volume? When the volume goes up, your cost will be higher. Nowadays, we are not really consider about the cost because hard disk costs are coming down. Around 20 years ago, cost might be a huge factor, but nowadays it's not a huge factor. However, performance is a major factor. Why? When we want to analyze large volume of data, if it takes a lot of time, we will have a concern there. So therefore, with the increase of volume, we have two types of problems. One is cost and the other one is a performance. When you are looking at analysis, we are looking at large volume of data. As I said, in operational system, we are looking at last month sales. When you want to look at last month sales, that means you have to accumulate all the orders that were processed in last month. This incidentally can be a large volume of data. So then just imagine you try to add up all the totals of the orders, which will take 10 minutes, 5, 15 minutes, 20 minutes to run. Will that be feasible? So those are the considerations that you need to make. So with the what are the challenges we have? One is the storage. And when you have how to store this, what are the techniques that can be used? And the processing part of it, how you are going to process this. Are you processing at once, end of the day, monthly? What is your processing design? How are you going to access your data? You have the data, large volume of data. How do you provide this data to be accessed by the users? So then we are moving into the second factor, which is variety. Now, when it comes to large big data platforms or data warehousing platforms, we are not dealing with one source. For example, we want to analyze our employees' performance with their qualifications. Qualifications will come from HR system. Performance will come from some other production system. You have to amalgamate these two data. Unlike in operational database, where you look at what is his performance today, HR matters what are these people's qualifications. You don't do any amalgamation or combined analysis. But when it comes to data analytics, you have to do an analysis of multiple systems. Sometimes it can be different sources as well. For example, let's say you are doing a land sales. So you want to look at what are the sentiment analysis of that particular place. How people's sentiment about this particular place. For example, some city A, you want to sell a land in city A. What is the sentiment of that particular area of the people, which you have to get from the web? You have the land properties details with you in a relational database, but your sentiment data will come from different source. If you are looking at ice cream sales, for example, you want to see your past records, customers data, which is coming from your relational databases. But item like ice cream, it's heavily correlated with the weather. So you want to know what is the weather tomorrow for in order to predict the ice cream sales. So how are you going to do that? You need the web data or the web service data. So you have to connect with multiple varieties of sources. So it can be a structural variety, it can be a format, different source of variety. When it within the structural variety, it can be the database type, and also the data that you are getting in. Remember, you might not get the direct access to the databases. They might tell you, okay, we have this data, but we can't give you the access. They will give you text files. They will give you web services. That is the medium in which data get delivered. On the other hand, they might come and say you can't access our data on this particular time. HR team will come and say at 12 p.m. we are running a 12 a.m. we are running our day end process. So you can't touch our system that day, that time. So you have to have a different time variety as well. It's not only about the data, it's all about accessing and delivering part as well. So third way that we are looking at, that is velocity, speed of creating data. Now you know in your physics you may have learned velocity is rate of change. Here our focus is rate of change in data. Now when we say velocity, we will always, our mind goes to how data increase. But remember, in here, velocity means not only the data increment. It's about data changes and data modifications. When you say modifications, it can be deletions as well. Structural changes. So everything you need to consider. Then velocity is not only about the creating data, it's about storing data as well. Now, sometimes you have the data in text files. How often you are storing that into your databases? Next point is not only the storing part, how are you going to analyze them? Are you going to analyze them daily basis or hourly basis or month-end basis? Various aspects you need to look at. So velocity is not only about the creation speed, but also the analyzing speed as well. Now we have two areas. One is speed of data generation and speed of data processing. So your source systems are generating data, and as an analytical platform, you are processing the data. So if your data generation is slow and your processing speed is also slow, then your cost is little, very small. The next one is your processing is slow, but you want to process, sorry, your generation is slow, but you want to process this very fast, which is a little unlike scenario, hypothetical scenario, even that your cost would be a little higher. The next option would be your generation is fast, but your processing is slow, which is the typical case in data warehousing. Typically, in data warehousing, we don't want to analyze data as and when they are creating in the data sources. For example, if you want to compare this month versus last month's sales, if this month is on the 8th of some day, some month, 9th of some month, half of this month, you can't compare with last month. So typically what you analyze is last month's sales with the previous month's sales. So data is already generated. Data is fast, yes, but your process is very slow. Speed of data processing is very slow, which is a typical case in data warehousing. However, there are cases, depending on the requirement, there are cases you generate the data faster as well as processing is much faster. Now remember, at the start of your project, You need to decide which part you should go. Then you have an understanding about your cost and the timing factors. Right. So we are moving into the next V, that is veracity, accuracy of data. Now you might ask, why it's problem for data analysis? So if I recall, we are looking at V's of data in data analytics or big data. Now sometimes this data, for example, let's say you are creating an order. When you are creating an order, at the time of data creation, you don't worry about customer gender and his other details, marital status, where he's working. So operational data, you don't need those data. However, when you want to process or analyze this data, those data is very much important. So accuracy is very much important. Can we rely on this particular data source? Context within the analysis, that is, when you want to analyze with some data, depending on the context, some parameters are required. Occurrence will veracity. How the veracity can be occurred? Number one, which is first one is very common. At the time of recording, data is invalid. Sometimes users don't consider about some data points. For example, for a person who is creating an order at the supermarket point of sale machine, particular cashier might not really interested about customer's gender or marital status. He or she might enter some invalid values. So at the time of data entry, data is wrong. Second one is the most difficult part to address. That is, at the time of recording, data is correct. But remember, systems are evolving, not your stored data. Now, let's say you are recording the customer's data. Somehow you said that, okay, I want to collect the data. So you are keeping the customer's data, his gender, his marital status. But marital status can change. So with the marital status change, his buying patterns may have changed. But in your system, it still says he is into some other marital status. At the time of recording, data is correct. But systems has evolved, human has evolved, but not your data. This is a very significant problem in telco, banking, and insurance industry. So veracity is very challenging task when it comes to uh, any of your systems. So you need to address how you are going to uh, rectify your data errors. Right. Next thing is these V's will come together. They won't stay individually. They will come together. When you look at a source, you have the variety, volume, velocity, veracity, and various ways. Very important thing is, what is the value we are bringing out of this data? So all this variety, volume, velocity, veracity are challenges for us. High volume of data, challenge for us. High velocity of data is a challenge for us. But how are we going to overcome this challenge? We will overcome this challenge only if we have a value out of this. So first and foremost, you need to identify what is the value that you can bring from this system or data. Right. So this is a summary. I put them all together. So you can see the volume is a scale of data. how large these data volumes are, volume, velocity, how the number of records, social media record. If you look at social media nowadays, Facebook growing very rapid rate, volume. If you look at the post, likes, reactions, sharing at a quick number. Then the variety, like different types of data. It can be structural data, it can be unstructural data such as text, images, videos, so on and so on and so forth. Then the veracity, how can we trust the data? Finally, we need to look at value of data. Now, there is something you to think. You don't get all these at once. For example, if you are looking at a supermarket data set, you have the customers data, which is in a database, structural database. So you have the large volume, it has recording large 5 years of data. It has the velocity, you will get 1000 orders per minute. So you have the higher velocity. Veracity also can be there because of the fact that you don't, some customers' information might be wrong, but you might not get that much of a variety. So it's always you don't get all these together. So we normally call complex data when we have all these together. So I leave you to think what are the complex data around you and why you are calling it complex data. So remember, since you know the V's analysis now, when you want to analyze your data set, look at the V's factors of your data. When you are starting a project in data warehousing or big data for that matter, look at the V's parameters, identify the V's parameters, and importantly, quantify those V's parameters. That's all for today on the V's of data. Hope you learned something out of this. Next day, we will be looking at different types of analytics. Thank you very much. See you with another video.